Hi Matrix, and welcome again. Today we are doing past paper 2, question 7 from 2019, the paper. And it's a 3D trig question. So let's start. Well, we've got a solar panel here with a base, and we are told that these are identical rhombuses. So let's see. So we've got these lines being identical. So this is X, and this will be X. This is X. This is X. This is X here. And then that line there is X, which means that this will be a half X, and this is a half X as well. Okay, so 7.1 says determine AK in terms of X. Determine AK in terms of X. All right, so they want AK in terms of X. Well, we see AK is in this right angled triangle. So let's just, so AK is in this right angled triangle. And it is, we've given this angle D is 60 degrees, and we know both of the sides in terms of X, so we can work that out pretty easily, either using Pythagoras or using our sine rule. I'm going to use the sine rule. Well, not the sine rule, I'm going to use the sine ratio, because we've got a hypotenuse and we've got the 60-degree angle. So sine 60, so we know that sine 60 is equal to opposite, which is the AK we're looking for, over the hypotenuse X. Sine 60, right, so we remember from our special triangles, and we just need to put our special triangle in so that we get the marks for doing that. So we have a 30 and a 60. And when we put our sine 30 into our calculator, we get a half. So if you forget, you can just actually check with your calculator. But if you're not sure about how to do these triangles, check out my trig video. It's not Matric trig, it was done in grade 10, I think, but you should all know that. So sine 60 is equal to, so 60 is there, so it's root 3 over 2 equals AK over X. So then we know that AK is equal to X root 3 over 2. Okay, now 7.2 says, write down the size of KCF. KCF. Okay, so they want this angle here. KCF. Okay, so, well, we know that KCF is in a rhombus. So we know that these are parallel sides. So it's only one mark, so I'm just going to say KCF equals 180 degrees minus 60 degrees. And I'm going to say interior angles of a rhombus. Maybe we should just say co-interior angles of a rhombus. And then, and therefore KCF is equal to 120 degrees. So we know that that's then 120. Can't really see that too well. Now, 7.3, they want it is further given that AKF equals Y. So this is Y here. And they want the area of triangle AKF in terms of x and y. Okay, so remember the area rule when we don't have a right angle triangle. The area rule is equal to a half AB sine C. Okay, and this refers to a triangle where you have an angle hugged by two adjacent sides. Okay, so this would be the triangle, and you're looking for the two adjacent sides, and then you can therefore find out the second, the entire area. Okay, so this is a 7-mark question, and that helps you to decide what do I need to get this area, because I want the area in terms of y, which is the angle that I'm given. And then you look and say, what were we given in the previous, what did we have to work out? Well, we had to work out AK, which is one of the sides. So we know that we need to actually get the third side. Sorry, the second adjacent side. So we need KF. But we look and we see we got a half x and x. The side are the two sides opposite KF. And if we look at 7.2, it's another clue to how we solve this question, because we were given the, we had to find the angle. I'm going to do this in yellow. So that was 120. Okay. And so we have this angle here. This, I'm going to do it in pink. And so we know this, and we know this is 120. Now, when we have two sides flanked by an angle, like we have with area, we know that the opposite side, a squared, is equal to b squared plus c squared minus 2bc cos a. Now, in this case, a is the side, is the angle, and then BC are the two sides. So that would be this here. Okay. Just to avoid confusion, in the green, we're talking about the C being there. The B could also be here. And then the A is here. And then, of course, this opposite angle is C. And then opposite the pink would be side A. If you're not too sure how these triangles work, check out the trigonometry toolkit I've done where I explain non-right angle trigonometry. So when we get this situation where we have an angle flanked by two sides, like we've got here and in green, we are either using the area rule to find the area, or if we want to get the opposite side, we use the cos rule here. So all that we need to do now is substitute in, because we want to get KF first, because using KF we will then find the area. So we know that KF squared is equal to B squared, which is, okay, so what I'm going to have to say is first KC squared plus CF squared minus 2KCCF cos 120. Okay, now I know that CF, we knew that CF is equal to X, but we need to say why we know that. We know that CF is equal to X, and that is sides of a rhombus. Okay. We probably need to say CF equals the CF equals AD, because that's the one we were given as X. CD equals AD equals X, sides of a rhombus. And we know that KC let's get DC as well, so that we know that these are all equal to X, and then we can say dk equals KC equals a half X, and that was given. So now we've said why we know that KC is X and why we know that CF is equal to X. We can then sub in the values. So KF squared, which is what we need to get, is equal to a half X squared, plus X squared minus a half X times X cos 120. And cos 120, we can put into our calculator, we get minus a half. So we get a quarter X squared plus X squared. A half times minus a half. This will end up being positive, a quarter X squared. Which in total is quarter plus a quarter is a half plus 1. So that's 1.5, which is 3/2. So 3/2 X squared. It's KF squared. Now we just need to root that to get KF, and we get root 3/2. Okay, let's make it root 3/2 X. Okay, so now we've got the length of KF. We know that AK, what AK is because of the previous answer. So now all we need to do is we need to substitute in that for the area rule. So we know the area. I'm doing it in different colors just so we can follow, because it's a 7-mark question and it's a bit tricky sometimes to follow. So now we're finding the area of this triangle here in green. Oh, that's a terrible line. Okay. Right, B squared is our AK squared, and our C squared is KF squared minus 2AK times K. We need to do our area. It's a half AK times KF. I'm glad, because that's much easier. Sine of Y. Okay, and then we've got a half, and then AK, which is we got previously was X root 3/2 times, and then we had root 3/2 X, and then sine Y. This is root 3/√2. So we've got, this is going to be, the root 3's are going to become 3. So the top is going to be 3x squared, and the bottom is going to be 2 root 3, which I want to rationalize the denominator so that I don't, well, let me just first show you what we get, and then I'll rationalize the denominator, because that's a concept that maybe some people actually aren't sure about. So this should be fine, but often they don't want to see an irrational denominator, although I think in this question they would probably give you full marks. I don't think that mean, but we would have to times by root 2 over root 2 to rationalize the denominator, which would then make a denominator rational, in other words, no surd. And because it's root 2 over root 2, I'm not changing the actual answer, because timesing by 1 doesn't change it. I just change the fact that there's a root 2 in the bottom. And then that would have root 2 times root 2 would be 2. So it would be 4 times 2 is 8. So then I would have 3 root 2 x squared sine y. And that's my final answer. I can't check on whether they're wanting you to rationalize the denominator for this question. Just do it just in case, because at this stage there's no memo on the government paper when I started this video. So yeah, this is the memo. If anyone finds a mistake with the work, please let me know in the comment section. But yeah, hopefully this should help you, and I will see you again soon. If this does help and you want to look at some more past papers and help with the solutions, please subscribe, and there you'll get updates on when I post past papers. And there's also playlists on there where you can see the full playlist of these past paper memos. This is the 2019 one, as I said. The 2018 and 2017 will be definitely correct, because I could check my answers against the memo.